Vanishing Lakes by Adrian, Anthony, and Devin.
Although at first thought the concept of vanishing lakes may seem quite unlikely, the phenomenon is actually more common than one would think. From hours to years, the time it takes for a lake to drain can vary greatly. However, in this video we will categorize the causes into two classes of anthropogenic and biogenic.
The picture below shows naturally disappearing Arctic lakes in Siberia. There are many ways for a lake to empty. First, we will discuss the occurrence of Arctic lake disappearance. Although in most cases, when permafrost melts in the Arctic, a lake generally increases in volume. However, in Siberia, there have been multiple cases where the exact opposite happens. Permafrost can be a significant part of the composition of a lake basin. This permafrost is placed amongst the soil, and when permafrost melts, the soil becomes unconsolidated. This causes the water within a lake to permeate through the soils. The basin, then left empty or very low in water, allows for an extremely altered Arctic landscape. From impacting migration routes and patterns in birds and mammals, to changes in the composition of plant species of the permafrost thawing area has significant impacts on the ecosystems of the Arctic. This picture shows the effects of climate change on lakes in Siberia. Above is July 27, 1973, and below is July 2nd, 2000.
The disappearance of moraine-dammed lakes are similar to Arctic lakes in that they can be very dependent on temperature as well. Moraine-dammed lakes are formed by glaciers retreating over a landscape. As the glaciers melted after the Little Ice Age of the 17 and 1800s, they deposited their carried sediments into high-columned moraines, which provided a natural dam that filled with water as global temperatures increased in the 1900s. These sediments are loosely fit together. However, in higher altitudes and latitudes, these sediments often freeze. A change in temperature melts this ice and causes these ice-locked sediments to come crashing down. This release results in the lake emptying large volumes of water.
A strong tide, increase of water, or even gravitational pull causing erosion can make these moraines collapse. It's all the power of nature. In fact, many of these dams break due to the massive water flows from the ice dams melting upstream and flooding the moraine lakes. This is especially effective if the volume spills over the sides of the lake, allowing for increased erosion.
Another type of disappearing lake is the intermittent lake. An example of this type of lake is Lake Srknica, which has a seasonal fluctuation pattern in water levels. From meters deep to less than 1 meter deep all in the same year, this lake seasonally becomes a wetland. This fascinating occurrence allows for changes in biodiversity in vegetation, biomass production, and transpiration rates of plants that have become exposed to the atmosphere.
Lake Aliotra, Madagascar's largest lake, is slowly disappearing because of sedimentation. Most of Madagascar was forest until the climate change began and the human clear-cutting practices for farming, burning, logging, and construction took precedence. With the removal of forests, soil erosion, silting, and sedimentation of the water system began. It is currently sitting at 20 to 30% of its original size and sometimes even appears to be completely gone.
When looking at a satellite image of Lake Aliotra, one can see the remnants of the original lake's basin. It is clearly visible that the lake has decreased in size. The Jefferson Island mine in Louisiana was a mine located above a salt dome near Lake Peigneur. During its creation, the Lake Peigneur area went through a series of evaporation and flooding stages, resulting in salt deposition. Over time, sedimentation occurred, covering the salt. However, due to the fact that salt has a lesser density than most sediments, it rose up and formed a dome of salt in the subsurface geology. During mining in 1980, the mine collapsed, causing a sinkhole that emptied the entire lake in just a few hours. The basin was increased in size by 28 hectares, and it took over 2 days for the lake to return to its initial water levels. The water that refilled the lake was salt water, causing a change in the entire structure of the ecosystem.
This image shows the subsurface geology of a salt dome. The density of the salt allows it to travel upwards to form an intrusion known as a diapir. Lake Peigneur is one of the best examples of anthropogenic impacts on a disappearing lake, as it shows how a miscalculation in engineering can have irreversible impacts on the environment. The immediate and obvious impacts of this catastrophe changed the way salt mines in Louisiana approach their methods of operations.